In this video, we'll be solving the following problem. Find the equation of the line tangent to the graph of the function f of x equals x squared minus 4 over x plus 1 at the point 2, 0. So let's think about what this problem is asking for. In the end, we are going to have an equation of a line. So that's where I'm going to start. And I know that there are a couple forms for lines. We can think about y equals mx plus b, slope-intercept form. We can think of we can think of y minus y1 equals mx minus x1, the point-slope form. And in this case, the second one, the point-slope form, is the one I'm going to use because I've been given a point. So here, this is going to correspond to the x1, y1 right here. That's our specific point. So our x1 is going to be 2, and our y1 is going to be 0. So we'll sub that in. Y minus 0 equals mx minus 2. Next, we need to think about what our slope is. Well, in our study of calculus, we've learned that the derivative of a function is related to the slope of the tangent line. In this case, if I were to find a formula for the derivative of this function and then substitute in for x, 2, I would have the slope of the line tangent to the graph when x equals 2. So that's exactly what I need here. I know that m is going to be f prime of 2. So my task is going to be to find the derivative and sub in 2. Remember that I can't start by substituting 2 into the function. That would give me a constant here. And when I take the derivative of a constant, I get 0. And I know that the slope of this function, the slope of the tangent lines to this function are not 0 everywhere. That would just be a horizontal line. And this is definitely not a horizontal line. So I'm first going to take the derivative and then sub in 2. So how do I take the derivative of this function? Well, I notice that this is a quotient. This is set up in as a rational function. We have a polynomial in the numerator and a polynomial in the denominator. And I have a rule, the quotient rule, to handle this. So I know the quotient rule, and I've memorized it, but there's more than one way to memorize it. And depending on what clicks with your brain, you might like one way versus the other. So I'm going to solve this problem twice, which means that you'll probably want to fast forward or skip through part of it and just listen to the part that appeals to you more in terms of how you think of the quotient rule. So if we say f equals u over v, we're going to leave out the x's for right now. One way to think about this is I think of this as a bookend kind of problem. I'm going to write down my u and my v, my u and my v, and I'm going to take the derivative of the first and the last right here. So the bookends, if you will, of this expression right here. And this reminds me that I'm subtracting. And all of this is going to go over v squared. So we're going to call this the bookends method. I'll solve it this way. And then there's also a lot of people memorize the little ditty that goes low d high minus high d low, square the bottom, and away we go. So d there is the derivative, and so we can use this. These are equivalent. It just depends how you think it through in your head. So first we'll do bookends, and then I'm calling this one the ditty. Okay, so if we're going to use the bookends right here, let's copy down our function again. This was f of x, so this is our method 1. And we'll save this one for later. F of x equals x squared minus 4 all over x plus 1. So I'm going to work this by doing some side work. Let me actually erase this one so we don't get distracted. And in my side work, I'm going to identify my u, the numerator, and my v, the denominator. So u is x squared minus 4, and my v is x plus 1. And I know that in my formula, I need to have the derivative of each of these, so I'll take the derivative of u. I'll use the power rule, which means I'll bring the exponent down in front here, 2x, and then I'll subtract 1. And the derivative of a constant of 4 is just going to be 0. So this is just going to be 2x. Down here for v, the derivative of x is 1, and the derivative of 1 is 0, so this is just 1. Then I can come along and use my formula. So I'm going to start with u prime v. So I need u prime v. U prime is 2x. V is x plus 1. Then I'll be subtracting. And then I'm going with u v prime. So I'll have u v prime. U was x squared minus 4, and v prime is just 1. Parentheses are really important in this problem. Otherwise, you can end up with mistakes just because you didn't distribute something through. Then the denominator is our v squared, so the denominator squared right here. At this point, I could just sub in x equals 2. If you're not very good at simplifying, if you are prone to errors, at this point you might replace all the x's with 2's and go with there. But I'm going to go ahead and simplify because this is pretty straightforward in terms of calculus problems. So distributing the 2x through gives me 2x squared, and then I'll have plus 2x, and then I'll have negative x squared plus 4 all over x plus 1 squared. Combining my like terms, the x squareds, gives me x squared plus 2x plus 4 all over x plus 1 quantity squared. And now I'm ready to sub in 2 for x. So I'll have 2 squared plus 2 times 2 plus 4 all over 2 plus 1 quantity squared. 4 plus 4 plus 4. 3 squared is 9. This is going to be 4, 8, 12 over 9. Both of these are divisible by 3, so I end up with 4/3 as my slope. So that was using the bookends, and I took advantage of side work because sometimes it can get to be a lot to handle the formula all right there. So there's nothing wrong with doing side work, and there's also nothing wrong with just jumping right in and doing it this way. That's in fact what I'm going to do on our next part. So this is a repeat. We're going to do the same work here, but with a different memorized version of the formula. So remember, if we had f equals u over v, we had this little ditty, little rhyme that we had there to help us remember, where we had low d high minus high d low, square the bottom, and away we go. That's what we'll be using now. So what's our function? F of x equals x squared minus 4 over x plus 1. So let's do it all in one without any side work. Our derivative, low, x plus 1, d high, I'm going to take the derivative of the numerator. The derivative of x squared is 2x. The derivative of 4 is 0. Minus high, that's the numerator. D low, the derivative of x plus 1 is just 1. Square the bottom, and away we go. I could simplify here like I did in the last problem, but since I simplified in the last problem, let's just jump in here with subbing in x equals 2. So I'll have 2 plus 1, 2 times 2 is 4, minus 4 times 1, and this will be 2 plus 1 quantity squared. So I end up with 3 times 4 minus 0 over 3 squared. I can simplify that a little bit, and I end up with 4/3, which I think is what I got on the other problem. So verified with a different method here. So let's see. Yes, 4/3. So let's come on back to the beginning here, and we'll replace our m with 4/3. So we end up with y equals 4/3 x minus 2. Might as well go ahead and put it in y equals mx plus b form. I'm distributing through here, minus 8/3. Now, how can we check this? Well, I love checking these using Desmos. So we'll just type in, we'll enter in the original function, and we'll enter in our equation of a line here and see if it looks tangent. And I've actually done this already. So here you can see the red line, the red curves are the function, and the blue line is the tangent line. So it's looking pretty good. It was supposed to be tangent to the graph at 2, 0. So you can see here at 2, 0, it sure looks like it's tangent. Looks like it's just touching right there at 2, 0. So it looks like we're good.